Good morning. We're back with another riveting episode of Identity Crisis. Good morning, Christos. How are you?
Good morning. Riveting? I love it. I love it.
Well, I might be overselling it a little bit.
Well, I like the excitement, I'll tell you that.
And I'm also a little disappointed that none of my, apparently my Restream title updates did not stick because...
Oh, no.
It still says that Joey's going to be here, but whatever, that's all, it's all good. So, anyway, today we're going to talk a little bit about how we ended up in the identity situation that we're in today, which is that it's fairly complex. Or it can be if you're looking in from the outside or if it's the first time you've ever had to do this. So I thought it would be a good idea to spend some time talking about, what we have to do, why we got here,
How we got here, right?
Yeah, why and how, and the kinds of things that drove us to this state. So that hopefully it makes a little bit more sense as you're going through some of the vocabulary. And so the first time that you are tasked with, I've got to build an app or I've got to build an identity thing for my app, that it can make some sense. So I mean, so many people we talk to, identity's it's an afterthought, right? It's oh no, we got to get somebody signed in, or I went through this tutorial and it told me to use platform ABC, and so I've got this user database and it's got all this stuff in it, and that's cool, but there are lots of issues, and so we want you to be able to make an educated, informed decision.
And maybe one of the issues is that we're not on Learn TV. Can't see us.
We're sending data.
We are sending data.
I wonder if there's a stream key change or something that happened that we weren't aware of.
Okay, let's carry on with this one because we do have people on our stream, which is fine. And then we'll take it from there. We'll speak to Gonzalez later. But yeah. Let's learn let's learn some history.
Yeah. All right. So, and again, just in case this is your first one, so we do a Monday, Tuesday show all about, or a Monday, Friday show all about building stuff with Microsoft Identity. Christos and I work in the identity division at Microsoft, where we go and help developers use our platform sustainably and successfully. On Tuesdays, we're kind of getting in a little bit more to fundamentals of the underlying bits that make a lot of the stuff that we talk about work. So it's intended for everybody, but if you've never used an identity system or never had to implement one or never had to work with one as a developer, we hope that this series will help get you up to speed on the kind of stuff that the kind of stuff we talk about and the kind of stuff you're going to encounter when it comes to building apps for the internet or building apps for your organization, or for your school or whatever group you might be affiliated with. So,
yeah, think of it as identity fundamentals, right? 101. Yeah. Starting from scratch, because we make a lot of assumptions on Monday and Fridays that certain things and we don't tend to cover them, whereas this one is intended to people that are just getting started with identity and they want to understand terminology, history, why we're choosing, what we're choosing, and how it gets implemented. So
yeah. And so you can join the conversation on our main channel, aka.ms/45 show on Twitch. We are 45 show on Twitch. Or you can join the Discord, where we've got, there's a whole group of people who come and we chat about identity occasionally. So let's get going. So the first real question is, what is an identity, right? Mm-hmm. And a lot of the part of an identity is sort of this combination of some information about you as a user, as a person, in the context of the application that you're using or the scenario that you're in. So we've got these two guys. We've got Joe and we've got Carl. And when they're at home, they're just Joe and Carl at home. There's nothing really specific about them. And so at home, they're 32 and 40 years old. They live and they got an address of where they live. Some of them have kids. Some of them own or rent their home. And so this is the kind of information that's important for them at home, right? And so if we were talking to them about, their personal life or about their home life, these are the kinds of things that would sort of foundationally make up who they are, right? So in that context, or in the home context, this is what makes Joe unique, and this is what makes Carl unique. And this kind of information is relevant, but it's not really relevant everywhere. It's only relevant in certain cases. So, like, let's say they go to work. So Joe at work is the risk director for the M&A department, right? So these are all little bits of data about Joe that we need to store, that we can then make decisions about, that we can use to make decisions later. Carl, on the other hand, is a risk instigator, and he works in sales. And he's been at the company for 7 years. So that combination of things may mean that Carl has access to certain things that only people in sales need access to, and Joe probably has some really privileged access, being part of the M&A group, where he's going to see, financials for other companies they might be thinking of acquiring, or he may see, he may have access to different levels of access based on the fact that he's only been there for 4 years, whereas Carl's been there for 7. So there are lots of different pieces of info about you at work. I mean, who we are at work is very different from who we are at home, because the context is different. The relevance of the information is different depending on who we are and where we are. The fact that I have 3 kids is completely irrelevant at work, right, to the work systems in play outside of things like HR and benefits, but those are kind of the kind of outliers anyway. So for most of me getting my daily work done, this kind of information, what group I'm in, what organization I'm in, how long I've been at the company, those sorts of things, those are the things that matter in determining what I may or may not have access to at work. And so right now, we've got 2 different identities. We've got these guys at home, and we've got these guys at work. But we may also find that there are lots of other identities that we sort of assume throughout the day. So on Twitter, Joe really loves funny videos, so he shares a lot of funny videos on YouTube, right? Carl is really interested. Carl's really interested in ties. He's really interested in wearing his dad's ties, and getting collars that relieve pressure off of his neck, right? Because he wears his dad's ties every day. So these things are not relevant at all at work, and in some cases they may not be relevant even at home per se, right? Like, these are relevant to Carl when Carl is interacting with Twitter. It's not relevant when Carl is interacting with his bank, right? It's not relevant when Carl is interacting with his his golf club membership website, right? It's only relevant in the context of Twitter, because that's the kind of stuff that he shares, and that's the kind of stuff that he wants to see. And so your identity is not really a singular thing. Like, you have your personal identity of who you are and the things that make you up, and your morals and values. But in terms of your digital identity, or your identity in these systems, a lot of that's driven by what is contextually relevant information in each one of those different systems, right? So if we wind the clock back a very, very, very long time, we find that it used to be that you'd have users and you'd have an app. And sometimes you'd have one app running on this massive machine, right? So physical access was all it took for you to be in there. And the fact that you signed in as a user really only mattered in the sense that that somebody had to sign into the computer. The fact that it was you, Christos, or me, John, did not matter whatsoever to the computer. The only thing that mattered to the computer was that there was a person there. And the computer handled all that on its own. And the computer was the size of a room, and most places didn't have more than one. If they didn't have more than one, then they might have 10, and you were the same user across all of them, because really who you were didn't matter. A lot of these were single-user machines anyway, so the fact that you could have multiple identities, or that you could have multiple people using the machine, was really largely irrelevant, right? But ultimately, the apps themselves are the ones who receive this information and then make decisions about what you can do within that context, right? So when I sign into Twitter, Twitter says, oh, this is John. These are all of the bits of data about him. These are the things that he is allowed to do. And that's only really valid within the realm of Twitter. So my ability to read a tweet, for example, or to post a tweet as myself, doesn't matter in any other context. It only matters within that application. And because the app itself is the thing that lets me post a tweet, it doesn't really matter that there are other places where I could do this. So what matters is the application is responsible for enforcing what you can and can't do based on who you are, and also interpreting who you are based on the information that it's given. And that's one of the big things about these identity systems, is that so many of them really are a provider of metadata about the user. The system itself doesn't typically make hard decisions. They just provide a bunch of metadata. So if you've got your application and you've got a database, and your database has users in it, in addition to all the other things that your application needs to do a thing, the fact that that user data is there in that database, that part is really kind of irrelevant, because ultimately your application code is the thing that says, oh, this is Carl. Carl does these things. He has access to accounts 1, 2, and 3, and thus when he tries to do this task, I can or cannot allow him to do it based on that data. So it's all about, really, a lot of these systems are all about metadata, about providing metadata back to applications in some form or fashion, right? So if we look at, this is Windows login prompt from what, like Windows 95, Windows 98? The funny thing about this was you could click the cancel button and still get to the desktop. So it's like, would you like to log in?
Those were the days, man.
Yeah.
Those were the days.
If you'd like to, you can, but you don't have to. So you can click cancel and just go straight in. And the reason for that was that the identity in Windows itself, like the identity of who you were to Windows, really was largely immaterial because it was only on that machine, right? Mm-hmm. And so applications themselves may have said, oh, well, you need to sign in because I've got your username in a database. Or maybe you don't need to sign in at all because it's just kind of assumed that there's one user who's here, right? It was more like you had the advantage of a user profile in the sense that you could store files in separate folders, but it wasn't enforced. Like, there's no real enforcement mechanism. It was mostly like a convenience feature, really, right? Mm-hmm. So that you could sign in, and one of your kids could sign in, and you would store your files in one place, and he would store his files in somewhere else. It was more of an organizational tactic rather than like a proper security thing, right?
Right.
So you can click cancel, and this would just take you directly to the desktop. And that's cool on a single user machine. That's fine, really, because it's single user, right? So if somebody's got physical access to a machine, then it's kind of game over anyway. And if you've got physical access, you can take a hard drive out, and you can copy all the data. I mean, you do sort of anything you need to with physical access. So a single user, non-networked machine, it's really not that big of a deal to have this kind of a thing, because what are you really going to log into, right? But then we decided to start plugging computers into each other, and that's when things started to get a little dicey, right? Because what started with, well, I sign into my computer, and then I might sign into an app or something like that, turned into we are signing into hundreds or thousands of apps. Right? So we've got all these applications, we've got all these user databases that drive all those applications. And the problem with this becomes every one of these users in these databases becomes a sticky note on your monitor or written down in a notebook somewhere, or worse, they're all the same password, right? And so you're using the same password everywhere, winter 2021 ! Or whatever. Sorry if we just called out your password, but people tend to reuse their passwords all the time. Because passwords are a pain, right? Mm-hmm. And passwords are especially a pain when you have 400 apps that you use on a daily basis, right? I mean, passwords are a pain when you have 10 apps that you use on a daily basis. Yep. So as more and more of these things started getting built, and more people were able to build things because the development environments and tools got more user-friendly and they were easier to use, as people started building more software, and we started building networks to connect all these things together, we ended up with a new problem, which is, okay, we got all these systems out here, and all of these systems all need to, I don't want you to have 5 different logins for 5 different apps, right? And if you're an organization, that's when things like directory servers started coming out. And so these were, C.L. Dubois, it's time to go change his password. So, sorry. Well, I mean, you could do winter 2022 ! Maybe then nobody would know. So the thing about it is, when in organizations in particular, so at work or at a school or somewhere like that, these big organizations, they might have hundreds of machines or thousands of machines. They might have a computer lab that has 50 machines in it, and they've got multiple computer labs. People started hosting applications on servers. So they would host, they'd have a database sitting on a server somewhere, and you would open an app on your computer, and you would use that, and you and many other people could potentially be connected to that central database, right? For doing different kinds of work or whatever. And so then you get into a point where now you might be doing work on data that is sensitive. You might be doing work on data that other people shouldn't necessarily have access to. So then we started having to differentiate between the fact that Carl could do one thing and Joe could do something different, right? And when we start thinking about, well, I'm sitting at my computer and I want to go log into this app, now we have to figure out, okay, well, I'm going to use the same set of credentials, the same username and password. I'm going to use it in all these different apps. So because now we are centralizing and using a common username and password, now we have to keep that somewhere centralized. So then we ended up with these things like directory servers, LDAP and Active Directory, and there are a bunch of different directory servers out there. Like Novell was really big. Like when I was in high school, we were all a Novell system. And those systems existed to store that user data in one place and then let a bunch of other applications and servers rely on that information, or even Windows itself or operating systems themselves. To be able to log into an operating system, you'd have to use an account that existed not necessarily on that system, but existed in this centralized database. But that has its own set of problems. Things like you really want to send a password over a network. And you kind of don't, especially 20, 25 years ago. People could, network traffic could be sniffed and everything else. And this is even within a private network, say at an organization. So I'm in a computer lab at my high school, and I'm connecting to something that's out there. Well, that's a private network. I mean, ideally, there are no malicious actors in your private network, but we all know that that's the truth. Or we all know that that's not true, that there are plenty of malicious actors all over the place. And so the fact that you're in a private network is good, but in that the rest of the internet is sort of disconnected from it. But at the same time, we can't really send passwords over the wire like that. It's not something we'd want to do. The other side to that is, well, how do we now have all these machines and all these apps that are doing things? How do they share this trust, right? How do they trust the fact that this user database they're connecting to is actually the user database they're supposed to connect to? Or that the messages they're getting from that user database are valid, right? Like how do you know as an application that's just sitting there cruising along on somebody's workstation, how do you know that the user who said they were, when Carl says he's Carl and types in his password, how do you check that password? Or how does that password get validated? How do you validate that actually is Carl and then get back the information you need? So that's what brought on all these new systems and protocols, things like Kerberos and NTLM and a bunch of all of the like X500 different protocols for validating user data and sharing user data. That's where a lot of these things came from. I've got this big academic network. They started a lot in academics and of course military and things like that. I've got these huge private networks. How do we share things, share credentials, or not credentials, but how do we share user data across all these things so that we're not asking Joe in risk management to remember 48 passwords for the 48 systems he has to use to get his job done during the day. The problem with that is it's a ton of infrastructure. It has a bunch of environmental dependencies. So when your clients and servers know about each other in that way, so when a computer that you're sitting at, your workstation, needs to know how to sign you in, and then also needs to know how to produce enough data to validate you against this other application that's running, you end up with this sort of integrated system where the client and the server have to know about each other and have to be configured to work with each other. So then it's like, okay, this is cool, but this means we have this sort of full vertical stack, right? Like I've got all of these components of this system and they all have to work together and know about each other. And in a private network or an organizational place, that's cool, that's fine to some degree. You go to work, they give you a PC and that PC is configured to work with work stuff and that's it, right? When I sign in to my computer, I sign in with my work creds, and that's it. I don't sign in with other accounts because why would I, right? And so, who's going to run all this stuff? Right? Now you got this team of people who's got to go run this big network and authentication system and authorization system that's sitting on the network somewhere. Who's going to run all this? And then who's going to configure all these different clients and servers to all work together to know like how to produce Kerberos tickets, for example, which is one of the mechanisms for validating these people and who they are. How do we do that, right? And bear in mind, we're still like in the mid 90s, right? So then we ended up with the internet being like a big thing, right? So this was Microsoft.com in 1994. I'm still not entirely sure. Like, I don't know if the page just hadn't finished loading yet, or I don't know what happened. But
was it Christmas at the time?
What?
Was it like winter or Christmas? It seems like snowing.
Yeah, I have no idea. I Googled for early Microsoft.com and found this image. In fact, we hosted this for a while.
Nice.
Yeah. So this is pretty cool. Pretty old, pretty cool. NT 3.5. So
yes.
I did use Bing, AZ Wildfire. Google is the Kleenex verb of searching for things on the internet. It's just, to Google is to be generic. But yeah, so the internet happened. And now suddenly all of these private networks that in some cases were quite large, now suddenly these private networks are now all out on the internet, right? Or connectable via the internet, right? So you've got all these networks that end up being connected. And pretty quickly we find that enterprise systems don't work across the internet very well. And more importantly, they don't work across trust boundaries, right? Yeah. So the fact that at work, I've got a work-issued computer or I've got a school-issued computer at school, and it's been configured to work with the servers that are at my school or at my work. The fact that that's there's this trust relationship between them, right? Well, by the 90s, people started having computers at home. And we got our first computer in 95. It was a Packard Bell 486, 66 DX2. I'll never forget that thing because it had a 480.
92.
Yeah.
Although it was a crappy PC.
I was 7 in 92. A computer's crappy. A 90s computer is crappy by today's definition anyway. But
it was monochrome. Mine was monochrome. It was a green hue, right? So it wasn't even it was like 1 million color monitor. So. Just to show you how old we are. Dinosaurs.
But so, ours had a 480 meg hard drive, which we actually sold for a decent amount of money because somebody, I guess BIOSes had the hard 512 limit, and somebody had an old PC and they needed a hard drive. And we're like, a less than 500 meg hard drive. We're like, hey, we happen to have one. I remember typing in like the number of cylinders and heads and all that silliness into the BIOS to configure disks. Man, that was a long time ago. Anyway, so the problem is with the internet and people now also having the ability to purchase a computer and leave it at home. Now things got a little weird because a lot of those protocols, they might work across the internet, technically work across the internet, but there's a trust issue there, right? So like in Kerberos, one of the big things is machine trust. So the machine itself trusts the central user database, the central directory. There's a trust there, so they can validate messages, verify messages that are sent back and forth. And I don't know about you, but I don't want my home PC to be controlled and managed by my organization, right? If it's my PC for playing Doom and playing video games and stuff, or doing just work at home, I don't want my work or my school to have control over that thing in the sense that you would need in order for those types of things to work. Plus, then there's the network question too of like, well, is it safe to do these kinds of protocols over the internet? And in most cases, it's really not, right? And back then, things like VPN and all that were so far away that it was so far away. Well, why do you vehemently disagree with this slide, AZ Wildfire? I'm talking about, remember, we're like at 1995 right now.
Yep.
Tell me why you're so angry.
Was he even born back then?
I'm see, this is weapons grade pedantry from AZ Wildfire, which is, it's too early in the morning to be dealing with this, but yes, technically you could technically, if you were big enterprise or big business or whatever, yeah, you could make this work across the internet. I'm saying, in generally speaking, most people at home and most businesses don't have RAS set up so that everybody can work from their house in 1995 on their Windows 95 machine.
Yeah, that was way too early for these things.
I should put an asterisk on this slide that says 1995. I mean, it says Accenture. That's a 1995 thing, right? Okay, anyway.
Yeah.
But then we get back down to the context thing, right? Of who I am at work is not who I am to buy a book. The kind of information that's relevant for me to buy a book is not the same kind of information that's relevant for me to do my work, to do my job, right? For me to work here is a completely different set of metadata, a completely different set of data for me to have access to whatever, compared to the data that, say, Amazon.com needs for me to buy a book. They need my shipping address and my credit card number, and that's about it. What else do they need, right? They need to know where to send it and how to get paid. And at work, they don't need to know anything about getting paid, nor do they need to know anything about where to ship things, because for work I don't get shipped things, and luckily I don't have to pay to do my job. So it comes back down to the context thing, right? And certainly you're not going to have Amazon.com say, "Hey, well, you need to join your computer to our work network in order for you to sign into this thing, to sign in and buy a book." But you very much need to sign in. We very much need to know who you are, because the information now is personal to you. Your credit card number, your shipping address, that kind of stuff, that's all personal to you. And it wouldn't an e-commerce platform wouldn't last very long if you could use other people's credit card numbers to make your own orders, right? And so we have to know who you are. The application needs to know who you are, and then also start segmenting data based on who you are. And that means you need to sign in. And so these big, networked, trust-backed protocols like Kerberos really just wouldn't work in that scenario, because they require a bunch of extra infrastructure and a bunch of extra work to make those work that wouldn't really work over the internet. So as we start pushing further into the 2000s, then we end up with phones, mobile devices in general. And yeah, we had Windows Mobile and all that sort of stuff, but things really took off when smartphones, like proper smartphones, came around. So when the iPhone was released, that sort of kicked off this whole new wave of, I can actually be productive on my phone. Like I had
You jumped 7 years. You went from almost 2000 to 2007, where phones actually looked like this, because that was a big jump. But I like it. I like it. It was a black time in history, like a black
yes,
between 2000 and 2007.
Blackberries, right? Because people are talking. So Blackberries, absolutely. Blackberries, again, required all this sort of heavy infrastructure to make them work, right?
Yes. And so a server. Damn.
And exactly. So you had an enterprise server, and the enterprise server had all these trust mechanisms and things like joining the directory, understanding Kerberos, and that sort of thing. And then they had mechanisms, like proprietary mechanisms, for the devices to identify themselves to the BES, to the enterprise server. So, and I had a BlackBerry. I had a lot of them, in fact. The other day, my kids found them, and they thought they were so funny because they were so small. My son was like, "Hey, a phone with a keyboard." Like, he just couldn't believe it. He's like, "It's like a little computer." I'm like, "Well." But so, like, I had an HTC Wizard. It was the T-Mobile MDA, I think. And so it was one of those ones, it's like this big. It's huge. It's the size of a piece of bread, and super thick. Mm-hmm. And you would push the top part, and the keyboard was underneath the screen, Yes. And it was like $150 a month for 2 gigs or a gig of data or whatever. Wow. Like, I don't remember what it was. It was like super expensive, but it was super cool because you had email on your phone. I did that though. My dad sold Blackberries, so he had a Blackberry, but my mom didn't. I met my wife in 2007, and she had a flip phone. Not only that, it was a prepaid phone. This is the first thing I did when we started dating was I bought her a phone. I was like, I can't. Like, I tried to call your...
With the US and flip phones, they're so popular, or they were so popular anyway before.
I don't know.
Because in Europe they were not all their age. But here, I mean, you look at the movies of the early 2000s and then everybody has a flip phone. It's just crazy.
Well, like, so I met my wife, and she lived in like an apartment building where when I would go to pick her up, you'd have to drive up and, punch a code in, or you had to call somebody, and then they hit a button on their phone to open the gate. I mean, this was 400 years ago, it seems like.
Yeah.
But the problem was her phone never had any minutes on it because it was a prepaid phone. And so I'd get there. So she'd call me and say, "Oh, come on over," So I'd get there and I'd like punch in the code to get the gate to call her. And then I'd hear, "Oh, this person's out of minutes or whatever. It can't be reached." It's like, and then she'd call me like from her house or something, or from somebody else's phone a few minutes later, like, "Oh, sorry," I was like, all right, I'm just going to buy you a cell phone. Because this is ridiculous. Like, you're 20-some years old. You need a cell phone that works. It's 2007. Get with the times, Mm-hmm. But so devices proliferated. And especially when we hit the smartphone, like proper smartphones in the... in like the late 2000s, 2007-ish, around the time of the iPhone and like the Android G1 and all those things. Now suddenly people are like, wait a minute, I can access the internet sort of in total. And then things like apps and all that started to come out. So suddenly, now the fact that you could sit at a computer, but you could also sit on your phone and access services and, more importantly, spend money, suddenly everybody wanted to go build apps, right?
Yeah.
So now we had people building apps, and they were building services that were purely delivered over the internet. Internet speeds got faster, computers got cheaper, and so more people had more devices. They had laptops, they had desktops, they had whatever. They had phones, they had tablets. So, and internet was cheap. Cellular internet was cheaper, I guess. So you could access, access services and read Twitter, and so all these new services started to light up, things like Facebook and whatever. And mobile was sort of the primary way people access them. Still is, really. And I don't visit Facebook on my computer. Why would I do that? Which, I mean, Facebook itself is sort of an awful company, so we can skip the Facebook example. But like Twitter, I don't really access Twitter on my computer. I access it on my phone. And so we ended up in this place where everybody had these devices they're trying to consume stuff, right? They're trying to consume data, consume their email, get their calendar notifications, access different services, buy things from Amazon, whatever it might be. And they're doing it all from these devices. And these kinds of devices, can't join, you can't join a domain on an iPhone, right? There's no concept of like a Kerberos KDC that lives in a place where an iPhone can do this. Not to mention, coming over cellular, they're coming over these untrusted networks. It could be a cellular network, it could be a Wi-Fi hotspot at a coffee shop, it could be Wi-Fi at somebody's house. There are all sorts of things that you really don't know about the link between the two. And so these sort of corporate enterprisey type protocols really wouldn't work for that. It's sort of at the low level, at the device level or at the OS level. So you really couldn't have this trust per se to say, this device can talk to this other server and we know who it is. When you sign into your iPhone, you're not signing in with a device account, right? Like there's a device account that runs the phone. And so because of that, we ended up with kind of in a position where people had tons and tons of different services that they wanted to access. And we needed reliable ways to know who they were and authenticate them and let them see their data in different places. So now I'm going to skip again another 10 years of the future to sort of now, right? And now we're in a place where everything's online. Cloud is cheap, network's cheap, computer's cheap. Whole new services have been born on the internet, right? Services that didn't exist prior, now they exist, and they exist on the internet. And entire applications are delivered. Browsers are so much better that you can deliver things solely in a browser. You can deliver a full application in a browser. Gmail, Outlook.com, all those sorts of things. And all you need is a relatively modern browser to do this. I mean, the entirety of the Office suite is online, right? I had to install Office yesterday, but I went weeks without installing Office because the Office web apps were good enough. Things like Dropbox and Zoom and Slack and all these different services that existed or that did not exist before, now they do exist. Mm-hmm. And so they're delivered across these massive server farms that are all over the world. And again, we're still coming back to that same point, which is it's really hard to do that sort of root machine level trust across these, right? With these existing protocols that we have. And the other big thing too is around the APIs themselves. So if you go build a new app today and you don't have an API that's available for it, chances are it's dead, right? Developers want APIs. People want to integrate things. It's not reasonable for me to sign into 45 different apps and consume whatever I need to out of each one of those and then put it all together. And so there are all sorts of services that try to plug these things in together. IFTTT and there's another one, I don't remember the name of it, but things like Microsoft Flow and Logic Apps and all that sort of stuff. All those things exist to connect all these different services together, right? The problem with that, of course, is that it's horribly abused, right? So the other day, we refied our house. We refinanced our house late last year. And I you know what? It wasn't the house refinance. I bought a car. So I bought a car from Carvana. So I had to go to the internet. I think you're muted or something, by the way.
I'm here.
Oh, okay, you're back now. So you remember I bought that car a couple months ago?
I remember.
Right?
Yeah.
And I did it with the Carvana or whatever because I was like, well, I'll try it. And I hadn't bought a used car in a long time. I didn't really want to go to a dealer. And they had a car I wanted. So we're going through the whole thing, and it says, okay, well, you gotta pay for the car. And so it said, you've got two choices. You can upload a bank statement that shows your current balance, that you have enough to pay for the car. But that means I'm going to be giving them my entire bank statement, which also shows them everything that I have paid for, which, I mean, whatever. But, I mean, that's not something I want some just random person having a copy of. It's got your bank account number on it. It's got everything that you need to go do an ACH transfer. It's got all the pieces of data that you need in order to, know a lot more about a person than maybe you wanted to know. But then also, they're gonna see a lot of extra data, and they're gonna see a lot of data that they don't need. This is probably a really good lead into like the decentralized identity stuff that we're going to talk about later this year. But it's we've got to share a ton of data for them to make one thing sort of make sense, right? So do you have enough money in your bank account for the amount of money that you want to pay for this car is a question. And instead of answering the question yes or no, they say, oh, well, you got to upload a bank statement. Or the other thing that you can do is you can sign into your bank with your username and password through this service, right? Now, most people are familiar with, sign in with Facebook or sign in with Google or something like that, right? This wasn't that. This was literally give us your bank account credentials because we're going to go screen scrape your bank account, right? In fact, some of the people who are complaining on the internet and about some guys who run a startup that does this, and it goes and it screen scrapes people's bank accounts, but they take in their credentials, right? Which is just mind-boggling. So I'm looking at this thing and it's like, I absolutely don't want to give you my bank account credentials because the fact that there's money in a checking account to pay for something is completely different from the fact that that login, that username and password gives you access to a checking account, a savings account, a retirement account, kid college accounts, stock account, like all that extra stuff.
Yep.
And I was actually super offended by the fact that this company even exists in the way that they do because, I mean, it's just such an awful thing to do to ask users for their credentials. But it still happens all the time, right? So we've got all of these online services. We have billions and billions of devices. All you need is your web browser, right? And most of these services, or most of these service providers, some of them own a lot of stuff about you. Or maybe they don't own it. They host a lot of your data. My Microsoft account has my Xbox stuff in it for video games. It has mail and calendars and chat and Skype and tons of different pieces of information about me. And lots of information that I've generated about me. Same for you. Same for anybody who's used, any of these services. Your Google account, right? My Google account has Gmail and Calendar and my phone service, Google Fi and all that sort of stuff. All those things are linked to my Google account. Files that you store in OneDrive or in Google Drive or in Dropbox or whatever. And so as these services have gotten larger and larger, if you think, oh, well, I'm going to go sign into my Google account with this random, I'm going to give my Google credentials to this random application so that it can go and manage my calendar for me. Well, you're not just giving them access to your calendar. You're giving them access to be you, right? It's straight up full on impersonation. And that's the big thing, right? Impersonation is essentially acting as you. It is assuming you and being you for the purposes of whatever task it is that you're trying to do, right? And that's super, super dangerous. And it was fine 20 years ago when you were signing into a computer alone. And Brett says that this is so alien because I normally just fill a duffel bag full of cash and walk into a showroom. I mean... Actually, I kind of feel like it'd be fun to do one day, just to see what they would do. Like, what would the look on the guy's face be?
Just carry that in pennies.
Small unmarked, small unmarked bills, just like a bunch of ones and fives. Maybe put some glitter on a few of them, like just. But anyway, but so like impersonation, you're letting somebody do something as you, and that's just super, super dangerous. Because if you think, if I gave you access to my. If I gave you my Google credentials, you've got access to tons of data about me. If I give you my private, personal Microsoft credentials, same thing. You'd have access to tons of different things, like my family. We've got accounts for the kids and stuff. Well, I'm the parent in that family, and so you've got access now to their email inboxes and things. So the days of just giving your credentials to somebody else, they're just very, very. It's just not good, but that's what it was for a very long time, and sadly, that's still what it is in banking. It's amazing that it takes 4 days for my mortgage payment to post, and yet in the time we've been doing this, the banks have transferred billions of dollars between each other in stock transactions. But whatever.
It seems to be retail only because the enterprise or wholesale is very different in banking, but I think the US is slightly behind. Let's not go there, but I do know for a fact that other parts of the world do not operate under the same premise. Like in the UK, you can send money from one bank to another or perform transactions instantly. You don't have to, and that's bank to bank. It's not using other apps like Zelle or whatever to send money, right? So this is directly banking to banking. I think it's just all their protocols or whatever the banks have. But it was funny because checks, even in the UK, they would take 5 days to cash a check. So you deposit the check today, it still takes 5 days for the money to appear to your account, which was crazy. I can transfer money instantly. Why can you not just check the amount on the check? Anyway, again, all their protocols, I suppose, or all their practices that stopped innovation. Hence the reason why checks died. Well, I think they died. They died here? Have they died here in the US yet?
No, people still get checks. I got a check the other day. Somebody sent me a check. I was like, what do I do with this?
Nobody has sent me a check.
My mother-in-law, I went with her to the store, and she's on, we were at the store. This was the last time we were in Michigan, and she wrote a check, and her check number, she's in the 6 digits of checks.
Wow.
Her check, the check number was 104172 or something. It was completely ridiculous. But AZ Wildfire says too, his house cleaner only takes checks, his landscaper only takes checks, and our landscaper only takes checks, and so we go to the bank, we go to the bank's website and we say bill pay, and they mail him a check. So it's just, we don't have to mail the check ourselves. We just set it up and then they go and mail it. But it's sort of amazing just how the rest of the world has gone on, and yet things like banking and insurance, all that sort of stuff are so far behind. But some of that's probably by design. Anyway, So the net result, though, is that impersonation is really not a thing that you want to do. If you can avoid it, you don't want to impersonate a user, because typically that means that you have a user's username and password, and that you can do literally everything that they can do. Mm-hmm. The reading my account balance in a specific account is very different from the ability to transfer money and create new accounts and do all that sort of stuff, right?
Yes.
I need you to look at one value in one account is very different from that. So then we get into these things called delegation. And delegation is all about saying, hey, I'm going to let this other entity do something with my data or do something on my behalf explicitly. So I'm explicitly saying this other thing, this other entity has access to go and do this thing for me, right? To read my account balances, whatever, to check my calendar like we've got here on the slide. But there's a discrete difference there in the fact that instead of it being something is assuming my identity, essentially putting on a mask and taking over who I am, the other way to do it is more of me saying, hey, here's a signed authorization slip that says, yes, you can access just my account balance for one account, right? And so I said that, and I signed my name on it, and I notarized it or whatever. And then this other person takes it to the bank and says, hey, this guy said that I could read his savings account balance, right? And that's it. So now the bank isn't responsible to enforce that. The bank's responsible to say, okay, you're only allowed access to account 123, and you're only allowed to see the current balance in it. So the teller, sort of the agent of the bank, is the thing that has to enforce that. The teller's the one who says, hey, I'm only going to tell you this because this is the only thing that the owner has authorized you to do. And so we get into things like OAuth, right? OAuth tried to solve this by doing this whole concept of selective delegated access.
Where do you remember when OAuth came to be? Like the first run?
OAuth 1 was 2010, I believe.
Wow. 10 years.
It was a long time ago. OAuth 2 was 2012 because OAuth 1 I think had a lot of problems. It didn't work well on non-browsers and stuff, so OAuth 2 came out pretty quickly after that. I do remember OAuth 2 seemed to languish with lots of different drafts. And so the problem is you had certain companies who were implementing different drafts of it, and they weren't necessarily all compatible. So like Facebook was doing OAuth draft 34, and some other company was doing OAuth draft, blah, blah, blah. Mm-hmm. And so the whole point of I've read some of the OAuth RFC AZ Wildfire. It's not the most exciting reading, so I can't read it all in one sitting, but the whole premise was this user's going to say, cool, I'm going to let this application read my calendar. I'm going to let this person read my bank account balance on account 123. The server itself, the thing that gated access to this, needs to know about both the user and the user's data, but then also know about these other applications or these things, these other entities that want to read that data. And that's the key. Is that instead of it being, I give you my username and password and you just appear as me, instead, I give this authorization to this other application, this other thing, and the central server, the Gmail server in this case, or the bank server in this case, needs to know about this specific application that's going to be trying to access it. That's when we get into the whole thing about app registrations and clients and that sort of thing. So the fact that you have to say this application exists is a thing that the server needs to know about. And so this works. Like this is still a thing. This is still something we use quite a bit today. And so OAuth is a thing that says that sort of defines a lot of what this interaction looks like, and this mechanism for saying I'm going to allow something else to manipulate my data, but only in certain ways. The big thing, though, you'll notice at the bottom, of course, is that OAuth is not authentication. So OAuth has been abused for authentication in many, many, many different cases. So you click a sign in with Facebook button or sign in with Google button, and it's going through OAuth 2 to access your calendar or whoever. And so what ends up happening is applications infer the fact that you're jdandison@gmail.com by virtue of the fact that that's the account that they have an access token to go and read your email with. So they're looking at the data they're getting back from the authorization server when they go to say, hey, this user allowed me to read their email. They're using that as a way to infer who the user is. But nothing's ever explicitly saying this is the user, right? So technically, your application still doesn't know who the user is. It knows who the user is to Google. It knows who the user is to whatever service you may be connecting to. But to your application, they're essentially unauthenticated, right, by that point. So then we get into OpenID Connect. And OpenID Connect is sort of a bolt-on top of OAuth 2 that lets you get authentication data, lets you get that identity metadata. So that's stuff that we talked about in the very beginning of Joe at Twitter is interested in subways and Carl is interested in rating his dad's tie collection. That information, that metadata about the user, we now, with OpenID Connect lets you do that, right? That's the whole purpose of it, is to be able to say, I know who this user is, and I also have these things I can use. I also have authorization to go and talk to these other services, to read their calendar, to read their email, to send email as them, right, for scheduling support or something like that. So OpenID Connect, the whole point of it was to sit on top of OAuth 2 to solve the problem of, well, I know I have access to do things with the user or with the user's data, but I still don't know who the user is. So that's really the whole reason that OpenID is here now, is that's why we get two tokens. One token is, hey, here's all the identifying information about the user, and then the other token that's received is this access token, which is used to go and talk to other things. And really, you should never look at an access token that's intended for another service, because it's not intended for you. And in some cases, you can't. In some cases, you can't read those tokens. Because they're not intended for your services. And so if you're relying on that for authentication, you're not actually going to know who the user is. And so OpenID Connect came about as a way to provide developers with a way to both sign a user in and also ask to go and access their data on their behalf. But what's nice about them, or maybe what's a little bit different, and part of what makes them kind of confusing and maybe makes them feel a little bit overwhelming, is that there are a lot of moving parts, right? And so if you look at some of the old patterns of how systems all interacted in terms of things like Kerberos and NT, there are all sorts of tickets that get generated, and there are central servers that host those tickets and blah, blah, blah. A lot of that's what's happening with OAuth 2 and OpenID Connect. It's just that it's happening in the browser in many cases, right? There are lots of other ways to do it, but in many cases, when you're sitting in the browser and you go to sign in, you might click a login button in an app, then you get redirected over to Facebook or Google or Microsoft or whoever to sign in. So now you're in this whole new place, you type in your credentials and click, 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 and you do whatever, and then you get sent back to the application, and the app's like, okay, cool, I know who you are now. And so as a user, it's a decent experience. I don't want to say it's fantastic, but it's good enough, right? But as a developer, when you're watching that interaction, it's like, well, what's going on here? A bunch of different moving parts. Like it used to be when I was doing like .NET stuff, enterprise .NET stuff 10, 12 years ago, you hit, user.identity.name and it just worked. You're like, okay, well, it works,
the simple
right?
days. You didn't have to think about that. Just give me the currently logged in user. I'm done.
Yeah, and like in websites and stuff, it was easy. But the thing about it is, to make that work in a website, I needed to be in a domain-joined Windows machine that was running IIS, that was configured, that was joined to an Active Directory domain, that had domain controllers sitting behind it, and all the Kerberos stuff configured. So I didn't configure that as a developer. I just consumed it. And so in my mind, because I was, I was like 25 and petulant and whatever, I was like, oh, this is super easy, blah, blah, blah. And it was super easy because a bunch of other people had done a bunch of work to make it easy for me. But it was also because of all of this underlying machine trust that was happening underneath. I didn't see most of it, and I didn't really have to worry about it. I didn't have to understand how it interacted. But it did mean that I had to have a ton of infrastructure available for me to make that app work. And it also meant that I couldn't pick that app up off of that server and go host it somewhere else without all of that environmental infrastructure up and running and it's still being there. And so now I think the big difference, or at least the thing for me when I was getting into identity a lot about 10 years ago, was you see a lot more of this happening. And a lot of it's happening in the browser, and a lot of it's happening over untrusted networks because it's happening over the internet, right? And so the browser you start to see a lot more of these interactions and how they work. And it can feel overwhelming and can feel very confusing. And luckily, a lot of the complexity is abstracted by different libraries and things like that now. But just understanding sort of how all of it works, sort of at the core, just ends up being really overwhelming. But OpenID Connect and OAuth 2, those two things now, that's our current sort of modern stack for both authenticating a user and for authorizing a user. And it's made up of things like flows and grants. So the way that you interact with like a Windows Active Directory or some other kind of an LDAP directory, the way that you interact with that, it tends to be server to server, machine to machine. But the way that you interact with a web service that needs to know only your data, you end up being involved because you have to sign in. You don't want to give your credentials to some random super sketchy app on the internet. Instead, you're going to let them just do one or two things that they need to do. There's this really cool thing. It was a Spotify thing, and it would like make fun of you for your music taste, essentially. But when you went and looked at it,
don't even go there.
I remember you sent me yours. It was pretty bad. What was it called? I don't remember.
I am not engaging. My silence. I'm keeping quiet.
You need to. I don't remember.
I have to say, it is a shared account, so the whole family is listening to that same Spotify account. So it goes from Moana, which is a great soundtrack, all the way to what I listen. So
here we go. I found it. Let's go look at it.
Just put it on the screen for everybody to share.
It's called Judge My Spotify, right?
Yes. Excuses. I know, chicken man. It is excuses, but it's fine.
It would say things like, how bad is your Spotify? Why do you share an account? Just get a family plan to be done. That's what I did.
Because I'm a cheapskate.
So let's see what's going to happen. Oh, I'm in the wrong browser, right?
No, we can see it. So this one has already connected and authenticated against your Spotify, right? Or you haven't done it yet?
No. So it says I need to see your Spotify, right?
Yep.
So I've got to log in with Spotify, right? Now, you'll notice when we do this, I'm getting redirected over to Spotify. So in fact, I'm over in a Spotify thing because I don't want to give this random app access to my stuff, right? No way. I'm not doing that. So instead, let me get I need to get my password. So instead, I sign into Spotify and I say to Spotify, hey, it's cool if you let this app sign in as me. So let me get my password right quick. So here we go. So I come here and I sign in. Cool, I'm signed in. And now it's going to go off and read my stuff. It's going to go analyze my listening history. But by me signing in, because I'd already done this, it was a little bit different. But because I'd already done this, it didn't ask me. But see, it's already given me a bunch of static. But it only has access to read my account. It doesn't have access to create playlists or to read other things. It only has access to read my account, which means in my opinion, it's relatively safe. The entertainment value of this thing, making fun of my music, is cool with the trade-off of what's going to get to read my music, and it'll probably go and sell something. It's probably going to go sell something to somebody about it. But it's, music tastes or whatever, so I'm not really that worried about it. But so that's the whole premise: is I don't want to give this random app that somebody wrote at a place called pudding.cool access to my account. I'd much rather just say, hey, go and read my account, and be done with it from there. So that's sort of the whole premise of why how we've gotten here, I guess.
Yes,
how we've gotten
it is
here.
9:00, and I think we have a tight schedule, so we need to wrap this up. If you want to see the first iteration of what identity is, click on the banner at the top. We'll have a link to that. And thanks everyone for joining us today. Join us next week. We'll have the next iteration of identity fundamentals, and we hope to see you there. If you want to see us before then, join us on Friday. Thank you.
Yeah, we'll be back here on Friday and on Microsoft Developer on Friday. So we will see you then.